All right, so now let's move on to question 2. We have evaluate the expression. We have the absolute value of negative 4x minus 2y all over 3 at x is equal to -1 and y is equal to -2. So this is a substitution problem. Wherever you see an x, you're going to plug in some parentheses and fill it with -1. Wherever you see a y, you're going to plug it in with parentheses and substitute it in with -2. And then we just solve. Absolute value of 8 is just 8. And then you get your denominator to be 3. We're done. Okay. Let's move on to question 3. I could keep it up here for a second if you need it. All right. Question 3. We're asked to use long division here. Do we have to include any placeholders? No. So we have our divisor on the outside. We have our dividend in the inside. And they're just asking us to find the quotient. So x times what gives you x to the third? Good. Now we take the product and we get x to the third plus 3x squared. If we did it correctly, the first terms will cancel out. -2x squared minus 3x squared is a -5x squared. And then we go ahead and bring everything else down and repeat the process. So x times what gives us -5x squared? -5x. Take the product. -5x squared minus 15x. Subtract this. The first terms cancel out. -6x plus 15x gives us 9x. Let's bring the 27 down. Repeat the process. X times what gives you 9x? Take the product. We get 9x plus 27. Subtract this, and lucky for us, both of them cancel out. So our remainder is 0. Telling us that our quotient is x squared minus 5x plus 9. And we're done. Yes.
So you said on the test if we do have the remainder to not put it in the.
If it asks you in the question to just find the quotient, you are not putting the remainder here. But if it says find the quotient and remainder, or if it's like find Q of X and then R of X over P of X, then you're going to have, or D of X, your remainder over your divisor, then you're going to have it in. So you just want to read the instructions to see what it's asking. If it's just quotient, then it's just the quotient. Yeah. Yep, no problem. Any other questions? Yeah.
I can't see.
No, it's not. So I sent you the PDF document. You're writing on it. Yeah, that would be really cool if that was a thing. Yeah, no. All right, let's keep going. Question 4, we have factor the expression completely. So you want to identify your P is really like your X in disguise. And so this last term is really your constant, your C value. So we want to find factor pairs of our C, bless you, negative 12 squared, that add to your B value. Your B is Q. So B is equal to 1Q. And then your C is equal to negative 12Q squared. And your A is just equal to 1. Okay. So anytime you have like a variable as like part of your C value, just ignore it initially and just hone in on the coefficient. And not even negative 12, just hone in on positive 12. Factor pairs of 12, we have 1, 12, 2, 6, 3, and 4. And then that Q squared, if we want it to add up to 1Q, we need to separate the Q squareds. So we're going to put a Q next to each of our factors. Because if we had just the Q squared next to one of the numbers, it wouldn't add up to Q. We would have different like terms. Here, these are all like terms now. Like terms, like terms, like terms. We can combine them. Then last but not least, we're dealing with a negative Q squared, so we need a manipulation of negative numbers here. And so of the 3 pairs, how would we manipulate using negatives for it to add to positive 1? Exactly, negative 3Q and positive 4Q. So now knowing that, we can set up our answer to be, we have our P and our P, since our A value is 1, and then we fill it in with a minus 3Q and a plus 4Q, and that's it. Questions on this? Yeah. Yeah, let's move on to page 3. Question 5. We're asked to solve the polynomial equation for y, which means anytime it says for a variable, we're isolating whatever that variable is. We want to get it all by itself. So let's rewrite. If we want to get the y all by itself, we need to first take the square root of both sides to get rid of that squared. And so we're looking at 3y plus 5 is equal to just 0. Then let's utilize some inverse operations. Subtract 5 from both sides, and you get 3y is equal to negative 5. Last but not least, let's divide both sides by 3. So our y value is just negative 5/3, and we're done. Move on to question 6. Solve the linear equation for x. So now wherever you see an x, this is a mistake. It should be for y. So there is no x here. So wherever you see a y, I'm going to highlight that in blue, and we want to get y all by itself. First, I noticed this plus 4. So let me rewrite the whole problem. And that plus 4 is the same as plus 4 over 1. We're going to have to get a least common denominator there in a moment. What do you think our LCD is going to be for our fractions if we have 1, 3, and 6?
6.
Yeah. So that first fraction we're going to multiply by.
2.
Mm-hmm. Excellent. That second fraction
6.
and that third fraction. Yeah, exactly, by 1 over 1. Leave it as is. So now that left-hand side is all over 6. Let's use some distributive property. We get 2 times 5y is 10y. 2 times -1 is a -2. 4 times 6 is a plus 24. And then that right-hand side stays as is. Let's combine some like terms in the numerator over here. So we're really just looking at 10y plus 20 over 6.
22.
Yeah, 22. Thank you. You guys are paying attention. So good. Now, to get rid of that denominator, we can just multiply the entire equation by 6. And when we do, all the 6's cancel out. And so now we're just looking at 10y plus 22 is equal to -8y plus 4. Again, objective, get y all by itself. So we're going to combine some like terms. Let's add 8y to both sides. And then let's subtract 22 from both sides. So we're looking at 18y is equal to -18. And then last but not least, we can go ahead and divide both sides by 18 so that we get our y value to just be -1. And that's it. Questions on this one? Alright. So let's go ahead and move on to page 4, question 7, which is a Pythagorean theorem problem. We want to find the length of the missing side, which is side B. What's our Pythagorean theorem again? Exactly. A squared plus B squared is equal to C squared. The C is always going to be our hypotenuse. We'll just have our B be B here, and then we'll let our A be 9. So now when we plug in, we get 9 squared plus B squared is equal to 15 squared. 9 squared is 81. 15 squared is 225. Let's go ahead and subtract 81 from 225. And when we do, what do we get? 140. Good. And now we're going to take the square root of both sides. And so we get our B value to be 12. We're talking about triangles, so distance of the length of a triangle, side length of a triangle is going to be positive. And that's it. That was question 7. Let's go down to question 8. Again, I'm almost positive they're going to have a question like this on the test tomorrow. Perform the indicated operation and simplify. So see if you can factor first, whether you're factoring just using your AC method, maybe it's a perfect square trinomial, maybe it's a sum and difference formula, maybe you just pull out a GCF. But that should be your very first step. So with our 8a squared plus 16a, what can we factor out? Yeah, and then we're left with the denominator will keep as is. This is being multiplied by, now a squared plus 2a minus 24. What are factor pairs of negative 24 that add to 2? 6 and, yeah, negative 4. What about factor pairs of 10 that add to 7? Yeah, 2 and 5 or 5 and 2. Now this is a division, so we're going to change that to multiplication, and now we're going to switch the numerator and denominator. So our denominator is going to go up top here, which is our a plus 5. And our numerator is going to go on the bottom. Can we pull out a GCF for our numerator? Yeah, we can pull out a 2a, and then we'll be left with a minus 3. Yeah, you're right. Good. Now that it's all multiplication, think about this as one giant fraction, and you are just multiplying all of these binomials by one another. So we can do some color coding now. We have an a plus 2 up here, an a plus 2 down here. We have an a minus 4, an a minus 4. We have an a plus 5, a plus 5. 8a and a 2a, that could be simplified. And then this is its own entity, and so is this. Okay. So what can we cancel out? Can cancel out the blues, the yellows, the greens. 2a goes into 8a how many times? 4. So we're left with 4a plus 6 all over a minus 3. And this is the same as just 4a plus 24 over a minus 3. So either of these answers would yield you full credit. So let's continue. We're going to go on to question 9. Solve the absolute value equation. We have 3x minus 4 is equal to 8. The absolute value is all by itself, so that's great. First step is complete. Second step, we have to walk into the positive and negative version. So positive version, we drop the absolute value and leave as is. Negative version, we just take the positive case, but that right-hand side is now being multiplied by a negative 1. And now we can solve. So positive case, let's go ahead. Actually, in both cases, why don't we just add 4 to both sides simultaneously? Save yourself some time. The positive case, we get 3x equals 12. The negative case, we get 3x is equal to negative 4. And then let's go ahead and divide both sides by 3. So our two potential solutions are x is equal to 4 and x is equal to negative 4/3. Last but not least, we have to plug this back in to check to see if we have any extraneous solutions. So let's plug in 4. 3 times 4 is 12. 12 minus 4 is 8. Absolute value of 8 is 8. That does indeed work. Let's plug in negative 3/4. Negative 3/4 times 3 is -4. -4 minus 4 is -8. Absolute value of -8 is also 8. So both of these solutions work, which means your final answers are x is equal to -4/3 and +4. And we're done. Question 10 is an applicable problem, real life situation. We have the daily cost to the printing company to print a book is modeled by the function c of x is equal to 13 over 4x plus 1500, where c is the total daily cost in dollars and x is the number of books printed. We want to find c of 0 and explain what this result means. So c of 0, wherever you see an x, you create some parentheses, and then inside the parentheses, we're plugging in 0. Well, 0 times anything is just 0, so we end up with c of 0 is equal to 1,500, and in terms of units, it's $1,500. So that's what c of 0 is, but now we have to explain what this result means. Let's go back to reading the problem. The daily cost to the printing company to print a book is modeled by this function. C represents the total daily cost in dollars, and X is the number of books printed. So when 0 books are printed, our daily cost is going to be $1,500. That $1,500 is that base cost without printing any books. It's your definition of y-intercept, right? That initial cost before any production begins. So this means that when 0 books are printed, your daily cost will be $1,500. ... This is your initial cost before any book printing. Yeah, production begins. This was on, I think, exam 1, right? It was the last question of exam 1 in this course. Questions? No? Okay. Let's go ahead and move to page 6, question 11. We're at the halfway point, almost there. Solve the rational inequality and write your solution in interval notation. Lucky for us, everything is already on that left-hand side, so we just have to jump into identifying our critical points. Remember, definition of critical points or critical values are what makes our expression undefined and what makes it 0. So our two values of x are what? Yeah. When x is -4, this makes it undefined. So are we going to have an open or closed circle here? Open. And when x is equal to 3, this is going to make it 0. Let's look at our inequality here. Are we including 0? Yeah, so are we gonna have an open or closed circle here? Now let's create our number line from negative infinity to positive infinity. Let's put in our critical values, -4 and 3. At -4, it's going to be an open circle. At +3, it's going to be a closed circle. And now let's choose some test values. So what's a value between negative infinity and -4? -5. -5 minus 3 is a negative. -5 plus 4 is a negative. A negative divided by a negative is positive. I'm going to shade that in green. Now, what's a value between -4 and 3? 0. 0 minus 3 is negative. 0 plus 4 is positive. A negative divided by a positive is a negative. Shade this area in red. And then what's a value greater than 3? 4. 4 minus 3 is positive. 4 plus 4 is positive. A positive divided by a positive is a positive. So we're going to shade this in green. Now we're looking at less than or equal to 0. So is this positive or negative? It's negative. So in interval notation, we're looking at the red, which means our final result is or bracket. Good. That's it. Okay. Let's move on to question 12. Another inequality problem. We're dealing with end here. So the trick with end is you want to look for the overlap, the values that are shared, where OR just stands for all of the values. And you solve the inequalities separately first. So let's maybe create a little T-chart here. We have our 3/4 in parentheses, x minus 8 is less than or equal to 3. And then we have our 1/5 in parentheses, x minus 5 is less than or equal to 3. So now let's solve. I'm going to straight off the bat divide that first inequality by 3/4 and utilize some keep change flip. So that's the same as 12 over 3, and 12 over 3 is just 4. So we get x minus 8 is less than or equal to 4. Let's do similar procedure on that other inequality, dividing both sides by 1/5 and utilizing keep change flip. So we get x minus 5 is less than or equal to 15. And then for that first inequality, I'm going to add 8 to both sides, so I get x is less than or equal to 12. And in that second inequality, I'm going to add 5 to both sides, so I get x is less than or equal to 20. So now I'm going to create my number line. I'm going to put in 12 and I'm going to put in 20. That first inequality, why don't we have that be yellow? That second, we'll have that be blue. So we have x is less than or equal to 12. So we're going to fill in the circle, shade everything to the left, and we'll color code that in yellow. And then in blue, we have x is less than or equal to 20. So we're once again gonna fill in that circle, shade everything to the left. And now we're gonna color code this in blue. But remember, our end is the overlap, the values that are shared. Yellow and blue make green. So green is your solution. So let's create another number line, really just zooming in on just the green, which is at 12, closed circle, and all shaded to the left. So last but not least, to represent this in interval notation, what do we have? Soft bracket, negative infinity, comma 12, hard bracket, and that's it. Questions on this one? How do you guys feel about it? Scale of 1 to 5. Good. All right. Okay, let's move on to our page 7, question 13. Solving systems of equations. And we want to solve it or show that it has no solution. So in this particular example, I know in the sample final yesterday, we chose to use elimination. I'm going to use substitution here. So I see that the first equation, I can easily get y all alone by just adding y to both sides. So we get y is just equal to 3x. And that helps me out because now wherever I see a y in the second equation, I can just replace it with 3x. So we have 5x plus 2 in parentheses is equal to 22. And inside those parentheses, I'm replacing it with 3x. Now our equation is all in terms of x, so we can just simplify and solve for our x value. Divide both sides by 11, and so we get x is equal to 2. And now we can plug that back in to find our y. Y is then just 6. So our solution is 2 comma 6. We can check to make sure this works. 3 times 2 is 6, minus 6 is 0. Excellent. 5 times 2 is 10, plus 2 times 6 is 12. 10 plus 12, does that give you 22? It does indeed. So in xy coordinate form, our final solution is just 2 comma 6. And we're done. Question 14. We are asked to simplify the expression and eliminate any negative exponents. So let's zoom in on this. This 2 on the bottom is really just 2 to the first. And we have a bunch of x's, so I honestly would just combine these two first and then take care of the division after we simplify that. We'll take care of the green in the next step as well. So when you multiply terms that have the same base, what are you doing to the exponents? Adding them. So we'll keep the 2 to the second as is for now. Then we have our x 4 plus 6. Good. And then we have x to the 5 minus 1. Good. So now, when we divide numbers that have the same base, what are we doing? We're subtracting. So this is the same as 2 to the 2nd minus 1. And x to the 10 minus 4. Which means our final result is just going to be 2. Wrote my bubbles way too large. I'll write the answer first. 2, and then x to the 6th. Questions on this one? Right. Let's go ahead and move on to question 15, which is on page 8. We are asked to find the y-intercepts of the graph of the equation and write our answer in coordinate point form. So we have, bless you, definition of y-intercept is what? When x is equal to 0. So all we have to do is wherever you see an x, let's just draw some parentheses. And then inside those parentheses, fill it in with 0. This shoots to 0, this shoots to 0. So what do we end up getting? Y is equal to 1. So in coordinate point form, we just have 0, 1. Question 16, we're going to be using the quadratic formula to solve the equation. So let me scroll down. Okay. Our quadratic formula, again, to the song Pop Goes the Weasel, x equals negative b plus or minus square root b squared minus 4ac all over 2a. That's what we're using here. Now let's identify our a, b, and c. Our a is 2, our b is 5, and our c is negative 1. And we can substitute it in. So our x is equal to negative 5 plus or minus square root 5 squared minus 4 times 2 times negative 1 all over 2 times 2. 5 squared is 25. Negative 4 times 2 is negative 8 times negative 1 is positive 8. So 25 plus 8 all over 4. We get negative 5 plus or minus the square root of 25 plus 8 is 33, which can't be simplified anymore. So we get our final solutions for x to be -5 plus square root of 3 and -5 minus square root of 33 all over 4. You could have also written it as just the plus or minus. I just wanted to show you that we get two values of x. And that's it. If they told us to put it in coordinate point form, then it would be this comma 0 and this comma 0. Because these are your x-intercepts. Let's move on to question 17, which is on page 9. We have solve the radical equation 3 square root of x minus 2 plus 5 minus 17 for x. So we want to get x all by itself. Let's first, straight off the bat, subtract 5 from both sides. So we're looking at 3 square root of x minus 2 is equal to 12. Then let's go ahead and divide both sides by 3, utilizing inverse operations. So we get the square root of x minus 2 is equal to 4. And in order to get rid of that square root on that left-hand side, we're going to square both sides. And so now we just have x minus 2 is equal to 16. And then last but not least, to get x all alone, let's add 2 to both sides. So our final solution is just x is equal to 18. And we're done. Question 18. We have find an equation of the line that passes through the points -2, 5 and -1, -3. And we want to write our answer in our y equals mx plus b form, which is just another way of saying our slope-intercept form. You need to find the slope first. So our formula for slope, which is just our m value, which is this guy that we want to find, is delta y over delta x. When we're looking at two coordinate points, the difference between your two y values divided by the difference between your two x values. And so why don't we call -2 our first x coordinate point, and then 5 our first y coordinate point, -1 is our second x coordinate point, and -3 is our second y coordinate point. So when we plug these in, we have -3 minus 5 all over -1 minus -2. Two negatives next to each other give you a positive. So we end up in our numerator with -8. Our denominator, we get +1. So this tells us that our slope is equal to -8. And then we need to find our y-intercept, which is our b value. But we can utilize our point slope formula first since we have points. And we have our slope that we just found. So our point slope form y minus y1 is equal to m in parentheses x minus x1. Our y1 is our 5 here, but you can really use any point. You could have used the -3. And then our x1 is -2. And then our slope is -8. So now let's plug in accordingly. We get y minus 5 is equal to -8 in parentheses x minus -2. Once again, two negatives give you a positive. So we get y, zoom in on this, minus 5 is equal to -8x plus 2. Utilize distributive property. Y minus 5 is equal to -8x minus 16. Add 5 to both sides. And we get our final result to be in y equals mx plus b form, -8x minus 11. Telling us that our y-intercept is -11. Our b value is -11. And that's it. Questions? Right. Let's go ahead and move on to our page 10, question 19. And this is our last page. Because, yep, last page. Where we're dealing with a completing the square problem. So we have let f of x is equal to x squared plus 4x plus 3. We want to rewrite our f of x in standard form by completing the square, or you can use the formula x equals -b over 2a, which is our axis of symmetry, to help us find the vertex. So if you decided to use it with the latter method, actually, I'll show it to you guys both ways to give you guys variety. So this way is by completing the square. Another way by using your axis of symmetry. Okay. So let's do axis of or completing the square first. We have our x squared plus 4x plus 3. And this is equal to our f of x. Now, when you're dealing with completing the square, we immediately want our mind to think about our special key, which is our b divided by 2 in parentheses squared. And our b value here is equal to 4. So if we plug in 4, you get 4 divided by 2 in parentheses squared, which is just 2 squared, which is 4. And so this constant over here, we're going to brush that off to the side. So I'll just write move to the side. And so what we're going to do is we're going to look at our x squared plus 4x. We're going to add in that manipulative constant, the plus 4. That plus 3 is moved to the side. But if we add a plus 4, we need to subtract a 4 to keep everything balanced. So maybe I'll box this area so it doesn't get confusing. Yeah, essentially we're changing this quadratic so that it's in perfect square form. And now that we have this manipulation tool, right, adding 4 and subtracting 4 doesn't do anything to the equation, but it manipulates it so what we have in yellow, we can factor it completely. And that gets factored in to our x plus 2 in parentheses squared. And then we have this guy over here can be combined. 3 minus 4 is just a minus 1. So now we did it. This has completed the square. And this is really cool because now this is in our standard form, even though I like to call it vertex form, because we can easily identify that our vertex is just -2, comma, -1. And you can tell we have a horizontal shift 2 units to the left and a vertical shift down 1 unit. So it stems from, once again, our standard form, which is our f of x is equal to a in parentheses x minus h squared plus k. You can very easily identify your horizontal shift, your vertical shift, what your a value is. Is it going to be fanning up, fanning down? Yeah. So that is our answer. But now we're going to solve it again, just utilizing our axis of symmetry. I think you kind of are already picking up on it. I'll keep it zoomed out so you guys can see that. But once again, our standard form is this a in parentheses x minus h in parentheses squared plus k. And this axis of symmetry is really just our h value. So if we identify our a, b, and c from our question, our a is 1, our b is 4, our c is 3. Axis of symmetry tells us we're looking at -4 over 2 times 1, which is -2. This is our h value. How do we find our k? We plug in the -2 into our function. Okay, we plug it into our function to find our vertex, aka our h comma k. And so we get -2 in parentheses squared plus 4 in parentheses -2 plus 3. 4 minus 8 plus 3, which gives us a -1. And so this tells us that our vertex is once again -2 comma -1. And so now when we plug this into, this is our h comma k, color code so you guys could see everything. So now when we plug it in, we get our result. So our final answer, once again, we have f of x is equal to a is 1, so we don't have to put anything. X minus -2 is the same as x plus 2 squared minus 1, which is exactly what we got in that first method by completing the square. That's it. Questions on this one? Again, you don't have to do it both ways. You can choose your preference. If you're more comfortable with completing the square, go about it that way. If you're more comfortable using your standard form of a quadratic and your axis of symmetry formula, then you can go about it that way too. And then last but not least, we're actually going to use that information to sketch this graph below. So I'm actually going to take this guy and bring it down. Take our vertex as well. Save some time. And then we can very easily identify our y-intercept because that's just our constant. And then our x-intercept, we can just factor our function. Our f of x is equal to x squared plus 4x plus 3. That's the same as x plus 3, x plus 1. So if we set it equal to 0, our x-intercepts are at -1 and let's do ascending order. So -3 and x equals -1. Coordinate point form, -3, 0 and -1, 0. This all in orange. And now we can plot all of these points. Anytime you're graphing, before you even start graphing, put in the standard to yield full credit. Label your axes, label your origin, put in a proper scale. Almost all the time on assessments, you can just go up by 1s. I don't know how many times I've already said this, but it takes less than a minute to do this. And so many of you guys still don't, out of pure laziness. It's frustrating. For those who do, thank you. When I grade your papers, it makes me so happy. Okay, let's plot our vertex, -2, -1. And our a value is positive. So if our a is equal to 1, which is greater than 0, we're looking at a U-shaped. Why do I think about that after I plot the vertex? Well, because then I can write below this point, since it's going to go up, and I can label it as vertex. So our vertex is -2, -1. Now let's put in our x-intercepts. We have -3, 0, and we have -1, 0. Label these two. -3 comma 0. -1 comma 0. Our axis of symmetry comes down, cuts through that vertex point. So it's this vertical line at x is equal to -2. So x equals -2, which is our a dot o dot s. And then we can plot our y-intercept, which is 0, comma 3, and then reflect it across our axis of symmetry. It's 2 units, so it goes over here. Now we have a decent number of points to just connect the dots and create our U-shaped parabola. Last but not least, let's write our function. So we have our f of x is equal to, you can write it either the general way or the standard way to yield full credit. I'll just do it the standard way, x plus 2 squared minus 1. Which clearly shows our x squared stems from the origin. This clearly shows that you're doing a vertical shift down 1 unit and then to the left 2 units. Right? Vertical shift down, horizontal shift to the left 2, which is shown by our standard form. And then let's read the instructions one more time to make sure we covered everything. We sketched the graph, we labeled the vertex, we labeled the zeros, aka our x-intercept. Ooh, we forgot to label the local minimum. So we need to zoom in on that vertex and also state that this is a local min. It's a local min, minimum at our y is equal to -1. Okay, now we completed it. Full points, 5 out of 5. Yeah, so this was the last question on our sample final exam A. It was A, right? Yeah, cool. Okay, hope this was helpful. Let me stop recording.